सर किती वाजता चालू होतो?
हॅलो, कोण बोललंय?
मी किती वाजता चालू सुरू होतं?
Within 2-3 minutes, madam.
ओके ओके
Within 2-3 minutes. Yes,
ओके
yes.
थँक्यू.
Shall we start? Are you ready?
Yes, sir.
We will start. Participants will join. Huh? We will start.
No problem. We can.
Yeah. Okay. Pallavi ma'am, go ahead.
Yes, sir. Yes, sir. Am I audible, sir?
Yes.
Okay. Good evening to all of you. I, Pallavi Thakur, welcome one and all present here on behalf of Organizing Committee at Bharatiya Vidya Bhavan's Sardar Patel Institute of Technology. I take this privilege to warmly welcome you all on this very first day of AICTE sponsored 2-week online faculty development program on insights into intelligent automation, machine learning and data science, and under this third FDP, which is data science and its applications. I find immense pleasure to welcome today's speaker, Dr. Pooja Raundale ma'am. Dr. Pooja Raundale ma'am is working as professor and head of MCA department at S.P.I.T Mumbai. She is founder director of Umist Consultancy, which is a technological startup. Ma'am is an AI advisor for Kage Technosolve, which is a technological startup. She is a faculty mentor in domain of AI ML for SPTBI. She possesses 17 years of teaching and 5 years of industry experience. Ma'am is a vibrant member of BOS for MCA in S.P.I.T, member of Academic Council S.P.I.T, Chairman Board of Studies MCA in University of Mumbai, and IQSC coordinator of S.P.I.T. She is approved professor for MCA in Mumbai University, recognized as PG teacher for MCA, recognized as PhD guide for MCA. Her PhD students are working in the area of AI, ML, and big data. In her tenure as a chairman of BOS, she instituted PhD in computer application in University of Mumbai and started credit-based grading system for MCA. She worked as a member of Academic Council, Research and Recommend Committee, Teachers Approval Committee, CAP Coordinator, and Trainer for Credit-Based Grading System for the MCA faculties, Subject Expert Committee in University of Mumbai. She is also associated with North Maharashtra University as a subject expert, paper setter, and examiner on panel of selection committee. She worked as a member of editorial board of several research journals, on various boards, session chair, member panelist, keynote speaker, referee, and reviewer for national international conferences. She has one patent, 11 national and 15 international papers to her credit. Her research interests are AI, machine learning, deep learning, and data science. Madam, I welcome you once again. And Madam is my HOD, so I must say, Madam is very cooperative, supportive. So, ma'am, I welcome you. And now I request Ma'am to take over the session and enlighten us. Thank you, Madam. Welcome.
Thank you, Pallavi. Thank you so much. I'll share my screen. Good evening, one and all. Thank you, Rathod sir, for keeping the session. It's really wonderful when our institute throws such a series of FDPs. You really feel proud, and I'm really proud. It's a proud moment to be a part of this FDP as a resource person. Thank you so much, sir. Thank you, Pallavi. Shall we start?
Yes, ma'am. You are most welcome.
Yeah. So, path from AI to deep learning. Yeah. I must say, love to go in flashback and picture badi honi chahiye. So I just want to just take you back 40 million years ago. On this earth, monkeys start turning into humans, and just consider this evolution process. It took almost 40 million years for a small organism to turn into monkey, and from monkey to Homo sapien, it took another 10 million years. And Homo sapien started, in the evolution process. Look at this last two creatures, we can say, or the humans. We turned into humans, and it took really million years to reach from this to this, almost 10 million years. How it takes millions of years for evolution and to gather that intelligence for a human being. Why I am showing you this is because we are talking about the intelligence. When we talk about the artificial intelligence, we must salute our human intelligence first, and it to become that intelligent person who uses who invents the artificial intelligence branch and all that, it really took millions and millions years. And tell you here one story that's a wise man's story. One wise man, he wanted to play this chess game with the king that time, and the king said, if you win, what will you the prize? And that wise man, he did not ask for the wealth, he did not ask for the land or anything. He asked that if I win, I will take one grain which is put here and just go on doubling those grains and go on doing this up to this 64 square cells or the cells, and whatever is the number of grains when you reach here up to the 64th cell, that much grains I will take. And the king said, oh, you are not a wise man, you are a foolish to take these grains, you could have taken all my wealth. And that wise man wins, and then king has to give those grains to him, and then king starts giving those grains. Then it started with 1 and 2 and 4 and 8, and then it becomes a handful, and then it becomes one sack, and then it becomes multiple sacks. And when it reaches to the 64th cell, the king loses all the grains in his kingdom. So here what I want to say is the power exponential. This is the power of exponential. When we say one cell, two cell, initially it takes a lot of time to reach to a high number. But later on, when it multiplies up to 2 raised to 63, it becomes 10 times, billion times, billions. And this is the power of exponential. And why I'm mentioning this, because the AI is increasing, the AI is growing exponentially. I would say corona effect. Actually, corona effect is a different term which is used in physics. It's in physics science, but nowadays this pandemic really taught what is the power of exponential to even to a common man. And here we have to realize the power of exponential, and this is the power AI has got, and this is how the AI is increasing and growing exponentially. Ray Kurzweil, he also says how exponential things work. Our intuition about the future is linear, but the reality of information technology is exponential. When we take a one step linearly, we reach only to the 30 steps. But when we take 30 steps exponentially, we really get to a billion. And this is what I want to tell all the participants, that the power which is with the AI is the exponential power. Look at this Moore's law, the fifth paradigm. See, this is how the calculations per $1,000. And this is how initially in the 19th century, 10 raised to minus 6 calculations per $1,000. And now how many calculations we could do per $1,000? See, this is the 2000 data. 2020 is again increased because of the GPUs and the TPUs associated with our systems. 10 raised to 8, that was the data on 2000. So computation power has increased, and the cost of the computation is enormously decreased. Exponential growth of computing. I just want to show you here the relative analysis of growth of computing in 1920, and look at year 2000 and year 2020. Actually, what it says, we have actually surpassed this. So calculations per second per $1,000. So this is something which is an insect brain. This is something a mouse brain. And these are the calculations a normal human can do. And all humans together, this is the power of calculations. And this power of the computation is increasing because it is exponential. It is a logarithmic plot. Our distorted view of intelligence. Now, so far what we have seen, artificial intelligence, the computation power, and in the evolution process, let it be the evolution of human beings, let it be the evolution of the earth or evolution of artificial intelligence. Initially, it is in the saturation, it takes time to take that leap. But once it takes the leap, the things increase in the exponential order. Now, look at the intelligence. So this side intelligence and this side time. This is somewhere the intelligence of ant. This is somewhere the intelligence of the bird, intelligence of a chimpanzee, intelligence of a dumb human being, and intelligence of the Einstein. We mark Einstein as the most intelligent human being so far on the earth. That's why we've taken Einstein here. And this is the AI intelligence, and AI intelligence is increasing. And generally now people are thinking that the AI intelligence has reached here. It is here doing some monkey tricks up to the chimpanzee level. So AI intelligence, the AI has got the intelligence which is equivalent to chimpanzee, and those kind of tricks are done by using the AI intelligence. But this is not the thing. The reality is different. see what's the reality. The reality is really different than what we look at that as our view. And this is the AI intelligence. And AI intelligence not only surpassed the human being, it has surpassed the Einstein, and it has surpassed everything here. And it has gone up. This is the AI intelligence. And this is the reality, which we have to accept. Human level intelligence station. Just understand the human level intelligence station, and we are thinking that the AI train will arrive, it will stop here, and then we can board in the AI train. But what happens? The speed of the AI train is so fast that it stopped and it just went. It went off. We could not even realize that the AI train came and it just went off. This is the highest intelligent on the earth, and this is the time. And look at this tripwire. Human brains become smart enough to create ASI. ASI is artificial super intelligence. Now we have actually entered into the ASI, and artificial super intelligence is now doing wonders. Generally, it takes decades for the first AI system to reach low-level general intelligence, but it finally happens. A computer is able to understand the world around it, as well as the human 4-year-old. And suddenly what happens, when it is with the humans, a 4-year child, when it has the intelligence of 4-year child, and when it matures, when it becomes the adult of 20 years, it takes actually 16 years. A proper 16 years it will take to take that matured human being intelligence. But that's not the case with the artificial intelligence. Artificial intelligence, with the exponential growth, anytime it can become mature, and it can gather the human intelligence, which is an adult human intelligence. And it's what it really wants to know. Even the 90 minutes after that, the AI has become an ASI 170,000 times more intelligent than a human. And this is how artificial intelligence has gathered that intelligence. It has surpassed the humans, it has surpassed the group of humans, and it has really become the artificial super intelligence. These are some evidences that not only present also is now changing. Look at certain evidences. Apollo 11 was landed on the moon using the computer that had 1300 times less processing power than iPhone 5. And our kids are now using iPhone 6, 7. So this is the power, this is the capability we are having right now on our fingertips. More computing power. See, this is the more computing power right now, which we really have supercomputers in our hands. In 2005, this was the size of the chip, which is 128 MB, and this size of 128 GB. And in 2030, not even 2030, but 2025, this much size chip will be 128 TB. These are certain evidences about the how AI turned the past into the future. This is Apple satellite carried on a Bullock car in 1981, and this is a Mangalyaan Mars mission orbit in 2014. This is how the times are changing. The purpose of showing all those diagrams and the pictures, how the world around, how the things are changing, how the research is happening, not only in computer science, but the other sciences research is happening, and the things are growing exponentially. And that's the benefit which is rewarded to artificial intelligence to grow further. This is cost per human genome. In 2001, cost per genome was more than $1 million. And now you can just see the cost per genome. Genome is what human humans have DNAs, and in the DNAs we have genes, and those genes can be further researched, and we can find out those features of the human beings which are very unique. So that for those research, human genes, human DNAs are researched, and that cost is a cost per human genome, and that has come down to this $1,000. So in 2020, the research or the cost of the human genome is $1,000. So the things are becoming cheaper and cheaper. The memory is increasing, the size is decreasing, and all the computing power is increasing, and that's the benefit is provided to the artificial intelligence to go further. Yes. Right now, in 15,000 rupees, you can really bisect your genes, and you can really read who you are as a human being. This is image processing, and you can really identify the image, the part of the image, not even when the image is complete, but even looking at the small part of a thing, and your image processing can identify the things. Speech recognition. We all know that how speech recognition has gone beyond the expectations. We know the Alexa and the other things, how they are working, and not only the speech recognition, but the research in NLP, which are the branches of AI, have gone beyond the limit and beyond the expectations. In 2016, machine learning has boosted Google's translation capabilities to near human level. So, machine learning, which is again the branch of AI, in 2016 onwards, this thing happened and it boosted the Google's translation. So these are the evidences which show that artificial intelligence has really gained the power of human intelligence, and it has surpassed that power. Now, this translations. So we can translate from one language to another language. This is another application. You are traveling to abroad, you need not learn their language actually. Just scan this menu card, and it changes or it translates into English language. So we need not learn even all the languages, and it works for us as a translator, not in the text, but it also scans the images and translates and gives you in the English or any other language which you need. Then the drones and the applications, virtual reality, these are the other evidences for the exponential future, and the future is again exponentially for artificial intelligence. The virtual reality, the games, 6D, 7D, 8D games which we see generally when we go to the hill stations or game stations. The virtual reality. The day is not far when a doctor need not have your, scan. He can just go through the body parts, and he can see any kind of a view, muscular or skeleton system or nervous system through a single channel, through a single device. AR, VR applications. These are the evidences showing that how the evidence is exponential future. Yeah, so far we are writing it, and we are asking for the searches, and we write down the queries in the text, and the Google searches for us. It's also possible now, which will be possible to draw certain images, and Google will ask us, okay, do you mean to search like this, or do you want to draw this kind of images when this is drawn? So that becomes intelligent, Then the doctors will perform those activities with the robots or dedicated devices. Yeah, already the autonomous cars are there in the market. So intelligent cars, smart autonomous drivers. Yeah, we all know the Tesla self-driving cars. They are more safer than humans. Now, certain applications which are in our lives, in our day-to-day lives, customer support. We know there are multiple such chatbots which are there, which are actually gathering the information and working on it, and it is providing the customer support. So customer support through chatbots or through certain AI applications, they are already there in the market. Personalized shopping experience. What happens when we are doing shopping? The humans like to shop on your websites only when the experiences are created, right? For example, ladies won't buy the saris until and unless they get that experience of the shopping, right? And that creating those experiences, creating those customized experiences for the person, user profiling is needed, and they really profile you. They find out what kind of a person you are, what kind of likings are there, and it gives you the recommender systems, gives you the recommendations, and it creates the experiences, the person you are. It actually creates the experiences for your type, and that's the future now for the even in the shopping. Finance, we all know finance sector is again ruled by IT, and there are many enormous applications which are using AI as a core. Smart cars and drones, they are using the AI applications, travel and navigations, social now the social media providing you certain features, but it is now becoming intelligent. It knows what you are, who you are, where you go, where you travel, who are your friends, what your friends are giving you, the comments, what kind of pictures you are uploading, what kind of visits you are doing. So social media gathers a lot of data, and this data is then channelized. This data is then used for even for the recommendation system or further analytics. Smart homes are going smarter now. We don't know the humans, but the homes and the devices are definitely going smart. So just look at our mobiles, our mailboxes. Mailboxes are also now becoming intelligent. You start writing a mail, you open your mailbox for composing, and you type your email ID. Down you will see there a dear. If I have written the Pallavi as an email ID, it will write dear Pallavi automatically. It will give you recommendations. So your email boxes are also becoming intelligent. They know what you're going to write now. It's engrams. Then when you are chatting, generally whatever words you are writing, it will suggest you same words earlier which you have used. So it's all the applications which come from the NLP, which identifies what is the next statement you are going to type in your chat boxes. And these chat boxes will give you different recommendations as per the different people, because when I write Sardar Patel, it will tell me Sardar Patel Institute of Technology, but somebody who is in the other state, it will write Sardar Patel something else, maybe Gujarat or anything else. So it is a personalized engrams which work for NLP to suggest you what to type next. So this is how the devices are going smarter, devices are going intelligent. Creative arts, this is another area. Security and surveillances. So security system surveillance is not only capturing the videos and recordings, but it is processing it. So video processing is doing multiple analytics, what kind of people are traveling, whether the people are doing fraud or anomaly detection, or what kind of facial expressions they are posing. Is there a moment, some kind of, we need to be alert. These are the things. So in every area, artificial intelligence is making a mark. We know Ola, Uber, needless to say that how it is earning without having a car and a shop to or any kind of a plant. They are having millions and the billions of the business all over the world. So many AI algorithms helping Ola for growing its business. As we already discussed, recommendation system and the mobile apps. So you go on Play Store and for any kind of a thing, there is an app. Even what to eat, what are the calories, what would be the nutrition in the food, what route I should take to travel, anything you just think of which help you need in your day-to-day life. For selection of your clothes, selection of your hairstyle, for anything there is an app, and all these apps are working on the some AI algorithm to give you the better experience of your life and to solve your problems of your life. We know Zomato, Uber, these are the apps. The core is AI. Yeah, participants, can you recognize this image? Yeah, anybody guess? Yeah, Tesla is one. Yeah, Elon Musk. Yes, yes. Is Elon Musk, the co-founder and CEO at Tesla, and he has, impacted the world. Everybody knows. He is the person where even the NASA goes forward and seeks the help. Yeah, showing this image, something I really want all participants to look at this image and what this image shows us, what it tells us. Yeah, anyone, what's this scene? Yeah, it's from Gita, and it's at the time when there was a war, right? So Krishna telling Arjuna, and that at the backside, that's a Mahakaya Rupa. So Krishna is showing Mahakaya Roop, and now what is the relevance here? Putting this picture is artificial intelligence has really become now a Mahakaya Rupa. It has really, taken the charge of entire world, and you would be surprised that everything is in under the surveillance. The day is not far when each one of us would be even in China it's going on. The people are under surveillance, what people are doing, whom they are meeting, what kind of statements they are making, where they're traveling, and everything is recorded by the government. And there are certain countries they are doing it but not revealing that they are doing this kind of a surveillance. So the day is not far that we say no कि भगवान सब देखता है, तो भगवान को पता है हमें झूठ नहीं बोलना है या कुछ नहीं करना है. Like that we used to tell our kids that भगवान की आंखें होते हैं, भगवान सब देखता है. But now we have to make the change in this saying, and AI की आंखें होती है और AI सब देखता है. We all are under surveillance. And this is how the entire world, what I'm seeing here, the highlighted part of the world, that's the AI is ruling all those countries and it is making the mark. So this is what we have seen, how AI has become very, very essential in our lives. So everything now we are talking about AI, everybody wants the things, the devices, even the kids to learn AI, everything is based upon AI now. All features, and everybody even in the marketing of real estate or anything, everybody wants AI to be as a backbone, some other AI algorithm to be used at the backbone, because Now, wherever there is a human intelligence, definitely artificial intelligence works beyond the capabilities of human beings. And that's how AI has taken the charge of the world. I can definitely say that. This presentation is starting from AI, machine learning, and then we will reach to deep learning. So we are seeing the path of AI, and now we really want to turn to the machine learning now. So how machine learning is a branch of AI. Now what machine learning has done in this? What is the contribution from machine learning? So let's understand. AI enables machine to think. So when we say AI, artificial intelligence, it actually mimics how machine thinks, that it's taken from the human, how human will work for this, how the human expert works, how we can mimic the behavior of the human and make our systems intelligent. In ML, it provides the statistical tools to explore and analyze the data, which is subset of AI. So the branch of AI is machine learning, and in machine learning, along with that, we provide the statistical tools to explore and analyze the data. So wherever there is a huge data and we have statistical tools, we can work on ML. Now what is deep learning? So deep learning is a subset of machine learning, and what it does, it mimics the human brain. Like we have neurons in our brain, deep learning actually mimics, and it works like how human will learn something. It tries to model the things, it tries to train certain models the way humans are trained. And then data science is a technique that uses all these in addition to the statistics, probability, and linear algebra. And this is how the branch of computer science, which is AI is further now grows in machine learning and deep learning. So what all possibilities are there for machine learning and what machine learning does? So as we have understood this, AI, machine learning is a subset of AI, and deep learning is again the subset of machine learning. So AI is enabling computers to mimic human intelligence and behavior. So it mimics the human behavior, and machine learning algorithms computers to learn, make predictions, and describe the data without being explicitly programmed. We'll see it later on how it works. And in deep learning, it's a black box learning. We never know how it learns. Even when we were small child or small children, we never know how we learned the language, how we learn certain concepts initially when our slate was blank, our brain was blank. We started observing, we started seeing, watching, listening certain words, sequence of scenes, smell, and everything. And we went on capturing the things and then derived certain relation between each and everything, and that's how we learned. So same way the machines or the models are trained in the similar way in deep learning to work on a dedicated area. So learning is any process by which the system improves the performance from experience. So it has to improve the performance on the experience. So more is the experience, better is the expert, we know. Let it be a doctor or a lawyer, or if the exposure is high, the more he works, the better he understands. And the same way in machine learning, it improves the performance by the experience. So machine learning is concerned with computer programs that automatically improve their performance through experience. So that's the definition for machine learning by Herbert Simon. So what machine learning and the normal algorithms are? See, when we are talking about the normal algorithms, the day-to-day, when we are talking about the computer, to a computer, we give data as an input. And on that data, whatever is the input, let it be an addition of two numbers or let it be anything, we have rules. So either rules or algorithms or a logic. So data is entered and the logic or the algorithm is entered, and this algorithm works on the data and it gives us the outputs or the results. So this is how the normal or the traditional programming is done. This is the traditional programming. In machine learning, the things are little tossed. Data is input And output is also an input. So data and output both go as input, and what it gives us the output, that's nothing but either algorithms or the rules. Okay, here is a trick. So what machine learning does, machine learning takes the input, it takes the output, and based on the input and output, it learns the rules. Unlike this traditional programming. So machine learning models, how are machine learning models and how it works? So the basic idea of machine learning is machine learning algorithm gets the labeled data. Now why this branch is becoming, this machine learning is becoming very popular and how it is working because of the computation power. Now the devices are having high computation power with the in the cheaper rates, or the cost is very low, computational cost has gone very low. We have lot of IoT booming up and getting us the data. So we have data. Data is easily available on sometimes data on the social networking sites. So data about the surveillance, the data about the devices which are capturing through IoT, and that huge data we have, and that's why we can run algorithms, we can have the machine learning algorithms learn from it. So that's why we have, so two things are very, very important in machine learning: high computational power, high computational capacity, and we need huge data for that. So how the model works, this is the labeled data. So labeled data goes input in the machine learning algorithm, and then this machine learning algorithm, it learns, and this is the learned model. So this is the model it learns. And now this is the part of the training. So in the training phase, you need a data, you need the machine learning algorithm, and it learns a model. And in the prediction or in the testing phase, you have a labeled data. You give this labeled data as an input and you try to use that same model. So that same model worked on the labeled data in the training phase and the testing phase, and it carries and it gives you the prediction. So this is how your machine learning model works. This is the learning phase of a machine learning model. So in the core, this is the training data. The training data comes from, as I said, comes from the devices, comes from, it's a huge data which has structure, it may be a structured or unstructured data, and feature vectors it is extracted. So feature vector means, for example, we have a data of the vehicles. So when we want to classify the vehicle, which is a two-wheeler vehicle or a four-wheeler vehicle, every vehicle has its features like number of wheels, brakes, the disc, or the panel, or the mirror is there or not, or the engine, what is the capacity of the engine. So these are the features. These are the features of the input data. So it extracts the feature, it learns from the feature, and algorithm works on it, and it trains the model. And while, so this is the learning phase. In the learning phase, we give the training data. It works on the feature vectors. So sometimes feature vectors, extracting those feature vectors, we need to do the feature engineering onto it, selection of the appropriate algorithm, and training the model. Now what happens in the inference model? In the inference model, we give the test data as an input. Then similar way, we have to work on the feature extraction, feature vector, or feature engineering to the model, and then this model is now ready for the prediction. So we train the model first and the predictions, like we teach the children. So for example, in mathematical classes or the mathematics classes, we teach children and then we take the examination. So that's kind of a prediction whether what kind of intelligence they have gained through this. As I said, this is the training data. So training data about the vehicles, it may be a four-wheeler shape, two-wheeler vehicles, and these are the feature vector. So it talks, these are all the numbers because computers understand all about the numbers. And this is a labeled data because each data has to be identified. The data whether it's a bicycle. So all these numbers, they describe a bicycle. These numbers describe a boat. These numbers together describe a car. And these are the columns. Maybe these are the shapes and the sizes and the things which are needed to make this kind of a vehicle. And this goes as an input to the algorithm. This algorithm works on it and the model is trained. So here it helps for finding the inference. And whenever we want to test, so we give this as a data, this data, then the features are extracted and the label is not given. Now the model has to recognize what kind of a vehicle it is. Based on this data, it will find out whether it is a car or whether it is a what kind of a vehicle. So that is based on the feature vectors. But this model has to be trained first. Now what happens when we are training the model? Definitely the data plays very important role in the training the model. So for example, if you are teaching a child, if you teach every example, the child will learn all those possibilities. If we do not teach negative numbers to the child will never know there are negative numbers. So same way, how to perform and how to draw those inferences and what about the accuracies about those inferencing records or the data, that depends on what kind of a data you're giving for a training. And that's why this plays a very vital role in machine learning algorithm and in training the machine learning models. The life cycle of our machine learning programs. So generally, when we are dealing with the machine learning algorithms or machine learning programs, or talking about the training your model, which is using at the core the machine learning algorithm, generally the flow is defining a question, collecting the data which supports that, then visualizing the data, training your algorithm, testing your algorithm, collect the feedback, refine the algorithm if you need, and loop from 4 to 7 until the results are satisfying. So what model learns, first you will have to check how whether the training is going on in the right direction, whether it is learning properly, what are the learning rates, what are the learning things, and you will have to check the model. And then once you feel that results are satisfying, it's making those errors only which are permissible in that model, then you are ready with that model for the further predictions. So this is the life cycle of a machine learning model. Now again the question comes here, that is why machine learning? So why we have to use machine learning and why now? So which develops systems that automatically adapt and customize themselves to individual users. As we are really in this era, we talk about the customized things, right? We want customized houses, we want customized things. So same way, this machine learning algorithms, it learns as per the user's individual needs and as per the user profile. And it let it be a recommendation system or let it be anything, let it be the giving the experience. It works on the individual users. So for different users, it is capable of recommending the different things. Discover new knowledge from the large databases. So it also helps for the data mining. As I said, the data amount of data is increasing. So we need such kind of models which are very easy to train and easy to adapt and then later on easy to use. Ability to mimic human and replace the certain monotonous tasks. So these are the reasons why machine learning has to be used. Develop systems that are too difficult, expensive to construct manually because they require specific detailed skills or knowledge tuned to the specific task. And here we can use the machine learning algorithms or machine learning model for such tasks. Now why this machine learning and deep learning is taking leap nowadays? Well, the simple reason is flood of available data. As we already discussed, there's a flood of data coming from every direction and increasing computational power. So we have huge data and we have a huge computational power, and these algorithms are successful when you have a huge amount of data. So growing progress in available algorithms and theory developed by other researchers. So this is how the researchers are working continuously to bring up the research to train those models, getting more accuracy. Let me tell you that the deep learning has really taken industry to the 99.5% accuracy, even for for the visuals, or what we say, the vision computing. So vision computing, image processing, image detection, the accuracy is already reached beyond 95-97 percentage. So that's the accuracy and the increasing support from the industries. These are few machine learning applications everywhere, every nook and corner. If you see, everywhere there is human intelligence can be used. We can replace the systems and we can use the AI or machine learning models there. These are certain things which are related to machine learning algorithms and applications. So this is another list of machine learning applications where we can use machine learning. Is predicting commuting. We, as you know, when we are traveling, we use the GPRS system, and we know without map we do not proceed nowadays, and it estimates us how much time we need from one point to another point. It also tells us which route would be a shorter, which route has more traffic. So all those predictions, at the backbone there are machine learning algorithms. Video surveillances, social media services, email spam, and scanning your emails, customer support, chatbots, search engine result refining, product recommendations, online fraud detection. These are some of the machine learning applications. So the concept of machine learning is learning is equal to improving with experience at some task. So these machine learning models will grow all the time and improving their experiences. It's not that once the model is trained, it will not improve. You go on giving the data, a variety of data, and your machine learning model will be explored, which improve over task with respect to the performance measure P based on the experience E. So this is the concept of machine learning, and this is the machine learning concept. So we have examples for machine learning algorithms. So there are types: supervised learning and unsupervised learning. Regression classification belongs to the supervised and unsupervised. There's a clustering, and these are few machine learning algorithms. There's a linear regression, decision tree, k-means. These are some of the basic algorithms. There are plenty algorithms which work at the backbone in the machine learning model. So this is machine learning and unsupervised, supervised, reinforced, and these are certain applications related to those types of models. Recommender system, targeted marketing, customer segmentation, you may see some more, game AI. This is a reinforcement learning, supervised learning, classification, regression, and these are certain areas where it is dominating now. So as we have seen, types of learning: supervised, unsupervised, and reinforcement learning. Regression, clustering, and this is classification. Yeah, so this is a machine learning algorithm. See how supervised machine learning algorithm works. In supervised machine learning algorithm, see, this is your machine learning algorithm, and what comes in is a this is the data basically. So this is a raw data, and after working on this raw data, as I said, feature engineering or working for identifying the feature. So this is the feature vector. So this raw data is converted properly using the pre-processing on this data, and this is the feature vector. So data comes in the machine learning, and this data is a labeled data here. Okay, so the data and the labeled data. So labels along with that. So that's the input to the machine learning model. And once your machine learning model is ready, this is again a raw data, same feature vector, feature engineering is done, and now it is ready for the predictions or the expected label. So it may classify the data or it may do the predictions as per the model is trained. So this is the supervised. In supervised machine learning model, what you have is a labeled data. So look at this. This is very important in supervised learning. So whenever we can consider one example wherever there is a trainer in the class. So in the class, there is a trainer who trains the students for a particular course. So that is the supervised model. And when there is no course instructor for a particular learning thing, and the students learn their own, they don't know anything, but they start learning something, let it be a sports activity or let it be any particular course. When they learn their own, they deviate in any direction, but somehow they learn their own, and that is the unsupervised. So this is the unsupervised learning model. So look at here. So there is a no labeled data because there is no supervision. Nobody is there to tell about whether this is a car or whether this is a two-wheeler or it's a boat or it's a shape. Only the data is given. So this is the raw data. Features are extracted, but whether it is a car or whether it is a boat, it's not given to it. So machine learning algorithm learns it itself, and it gives the labels, like it classifies in zero, class 1, class 2, like that, the similar things. So similar data is classified in the similar classes without any label, and it creates its own class, or it creates its own way how it detects or groups the data together. And here then it's for the prediction or for the analysis, the same document goes, the feature vectors are extracted, predictive model is learned, which is already trained on the data, and this is the likelihood or the cluster ID or the better representation, because here we have not told that child whether this is a car or whether it is a sheep. The child is learning, this looks different, this has only 2 wheels, this has 4 wheels. So it will classify it as a cluster ID or the classes, different classes. So this is the supervised learning model. This is a regression. Now where we use the regression, I'll show you the diagram first. In the regression, we may use regression for any of the application where we want to predict something. So based on certain data, we want to predict. So for example, we have a data of the population of India. So starting from 2001, 2010, 2020, and then we want to predict for 2030. Or when we have the 100 years data and we want to predict something in the future, that can be done with the regression. Or we want to predict the house prices. So we have a data of the houses. Let's say in Mumbai, all the houses data we have, whether it is a town or whether it is a suburb, or the houses which are near to the stations, or the houses which are 1 BHK, 2 BHK, like that. And that becomes the features of the house. So like the area of the house, the number of bedrooms, the amenities in the building, and other things. So that becomes the features. And if we have this data and we train our model, this will give us the predictions. So for example, look at this. This has one feature which is a floor space, and this is the label which is the house price. So every record which has right now here, for simplicity, this record which is a floor space and house price. So for different floor spaces, the different house prices are given, and so this is a feature. This is one feature in this particular example, and this is the labeled data. So labels are given, and when we give this as an input to our model will try to fit those records and will try to identify what should be the line this linear regression, we'll call this as a line of regression, which will try to fit each and every record or the sample point over here, and which will identify the trend. What is the trend of the house prices? And whenever we want to predict some house price where we don't know the price and we want to predict, so we can do the prediction. So predictions are performed based on the house prices which are given for this particular data. So this is a labeled data, and this is the linear regression. Now here we could fit a line. Actually, sometimes it's not possible to fit a line over here. Then it becomes a non-linear. Okay. So in linear regression, it's possible to fit this line over here in the linear regression. So that is one of the algorithm. Classification. In classification, based on certain features, we do the classification. It can be any kind of, it can be humans, it can be anything, it can be the products, it can be certain profiles, and sometimes we need to classify them. And this classification algorithms are, many classification algorithms are there, and they use, basically they try to classify the things based on the data points like this. So K-means is one of the machine learning algorithm which actually tries to find out this distance between the points, and it actually draws an area for defining that particular group or that particular class, and then it identifies whether a point would be, suppose for example this point, whether this point should be put in this class or whether this point should be put into this class based on the Euclidean distance between this point and this particular k-means algorithm. And then why k-means, it may classify in k different classes. If you want to classify for 2 classes or 3 classes, 4 classes, so the related points would be classified in n number of classes. This is one of the linear classifier. Now see, these are the blue data points and the red data points. These are the recipients and the email length. This is particular example for, suppose we get email in our mailbox, whether to classify it as a ham or a spam, whether it's ham or spam. We may have a linear classifier, and the mailboxes are becoming intelligent to identify whether this particular mail is a spam mail, and it automatically puts that mail into the spam. So how it classifies? So it has a classifier, a new recipient, and the length of this. So if a new recipient and if the length is this much, then it is one class or it is another class. Like that it classifies. And this is a separator. So this line separates your emails being ham or spam. So that's why this is a linear classifier, because we can draw a line. How do you classify this data? So based on this. Now this is also a linear classifier. So there are, if you see this, there are multiple lines. So this is the space. In this space, we may draw multiple lines to classify these 2 types of mails. Right? So these are the possibilities. Now, which line to be taken and which line is the best suitable for our algorithm, and that can be taken from the cost function. If the cost function is lowest, we select that line for the classification. And this is the margin of the linear classifier. So this width is the margin, and we can select a line where each from this point, if you draw a line and you take a perpendicular distance from this and then take the total distance from this to this, the positive distance from both the sides, and you take that distance, average it out and see what value you get. If we get the lowest value for a line, that becomes our line of regression or the classifier. And there are certain algorithms to identify it. Now look at this. So here, these are some outliers. So these are certain points. Now this is a red dot, but which has come this side, and this is a blue dot which has come this side. Now linear classifier cannot classify this kind of dots. Okay. Now we need beyond this linear classifier. We need a classifier which can be a curve or which can be a different shape, which can classify perfectly all these points. For example, if we can have this line like this here, or maybe this line, if we can change this line like this, then maybe this classifier works for a good accuracy. But because this is a linear, this kind of a shape classifier cannot be possible. But here comes the deep learning. So deep learning will give you that ability where your classifier can be any curve, or it can be a very complex line. We may not say it a line, a complex structure which separates out those points. And we will see one such example also in later presentation. This is the learning process. Measuring devices, pre-processing, dimensionality reduction. Dimensionality reduction is working on your feature vectors. So there are certain algorithms which will give you exactly, or which will give you a good insight what features you can keep and how you can reduce the dimensionality. Then model learning and model testing, and this is how you can analyze your results. This is how the learning process goes for machine learning model. Now same thing for the email server, number of recipients, size of the message, number of attachments, and number of REs in the subject line. Based on these features, you can classify whether the new mail which has arrived is a spam or ham. So for example, this is a data set. Number of new recipients, email length, country, customer type, email type. So this is the target attribute, and you can say this as a label data. So this is a model training, database, reduction algorithm, and classifier model. And then it classifies. Generalized model. See, when we are training our model, how much to train, what should be the learning rate, and all that depends on what kind of a data it is, what kind of a cost function it is, and when to stop when you are training a model. And there comes these terms: underfitted, generalized, and overfitted. We will see in detail later on these terms. These are few learning algorithms in machine learning. And when we are training the model, sometimes we need to see the accuracy. So accuracy can be calculated like this. So for example, if you're classifying something, so you see whether your confusion matrix, what value it is given. These are the actual values and the predicted values. So you see the false and true actual values and compare with the predicted values, false and true, and identify those true negative, false positive, false negative, and true positive. Based on that, you can calculate the accuracy. And this is how you can compare the models and try to train the model. So what machine learning consists of? I'll just summarize here the machine learning. We have seen the classification, clustering, and regression. Classification and clustering look similar, but the technology is different. And classification and regression look quite different, but the technology is fairly similar. So this is what we have seen in the machine learning. So far we have seen the journey of computer science, you can say, or the journey from AI to machine learning. So we are midway. We have reached up to the machine learning, and we are going to see what deep learning and what all can be done in deep learning. So organizers, Pallavi and Sir, are we taking a 5 minutes break here?
Yes, madam, sir. Should we take?
Yes. We are supposed to explain the assessment. No? So only break
Yes.
for madam, not for participants. It's a break for madam.
Yes.
Okay. So you want me to share the slide?
Yes.
Pallavi ma'am?
Yes, sir. Assessment
Okay.
modalities.
Yes. Yes. Ma'am, go ahead.
Okay. Okay, hello participants. In this particular FDP, we are going to take basically three types of assessment modes. The very first one is learning evaluation sheet, where you need to create a day-wise, session-wise summary and list three takeaways for that. So whatever sessions you will be attending for every day, there is a format which is already uploaded on Moodle. You just have to download that format from the Moodle, and you just have to fill the summary of each and every session with three takeaways or three learnings that you got it from that session. So that is the very first thing. So let's say today is the first day, which is 7th of December. So for today's session, you will be filling the details, the summary for the morning 2 sessions and the evening 1 session. So everything is given in the sheet, date, time, speaker and session, the topic for the session, everything is included. You just have to write down the summary in between 100 and 300 words and the three takeaways from every session. Okay, and that you have to upload daily before 10 a.m. to the next day. So for today, you have to upload that sheet before 10 o'clock in the morning tomorrow. So deadline will be 10 a.m. at 8th of December for today's session. And rest of the sheet will be blank. Next day, you will be filling the data, keeping the first data as it is. Fill the data for the sessions which you have attended on 8th, and next will be the rest of the sheet will be blank. And the submission date for the sessions on 8th will be 9th morning at 10 a.m. And this will go on till till the last day of FDP. So that is the first assessment mode. You can get the format from the Moodle, which is already uploaded. Second mode is the assignment. Now, what is to be done? So any assignment which is given by the resource person on the given day will be considered, and that is to be submitted as per the deadline which is given by the resource person. So the same will be intimated and uploaded on the Moodle as per the wish of the resource person and as per the instructions given by the resource person. So anything which is covered by the resource person will be taken as an assignment, and it will be given on the, you have to submit it on the Moodle. The third, and which is the most important, is the final assessment quiz, which is basically 1 hour MCQ quiz based on all the topics which are covered during the FDP and which is compulsory to attend. Okay, so that will be available on the last day of FDP, which is 19th of December between 8 a.m. to 11 a.m. The time for the duration for that is 1 hour. So between 8 to 11, you can attend at any time, but you have to finish it within the 1 hour of that. So between 8 to 11, you can take any 1 hour of time and you can attend the same, and which is compulsory. So I again repeat, the final MCQ quiz is compulsory for everyone to attend. So these are the three modes with which we are going to conduct the assessment for this particular FTP.
Okay.
Anything?
I will continue, madam. Let me.
Okay.
To PDF or other screen also. I'm sure.
Only PDF, sir. Only PDF.
That's what. I'll have to stop sharing and again share. That's what. Just.
The Word format is there on Moodle, so participant can see that.
I'll tell other things also. Who are new, because of the older one, FDP1, FDP2, they know. But I believe there are at least 10-15 participants new in this particular FDP, so they should know the way we conduct FDP, and that's why we are explaining this. So first thing, ma'am already explained you that this assessment will be on Moodle platform. I think that is very clear now. So the new participants must be wondering where is this Moodle. So today, those who are new, we are going to create today night, we are going to create your Moodle logins, and the procedure will be mailed to you, or we will put it in the WhatsApp group, and accordingly you will have to log in tomorrow morning, and then you will get everything. So this is how this is where you will log into the Moodle. Electronics department, electronics engineering, or here there is an AICT FDP course. In this course, you will see that there are various courses out. this is your course, AICTE sponsored FDP on Insights into Intelligent Automation. So you enroll into this course using the key which we are going to provide. Now on this, once you enroll, then you will get under this course everything related to FDP3. So all the course material, I have already uploaded the course material for the next 3 days, and that is what is my main purpose of addressing you right now, because there are very important instructions given by the resource person who is going to take your session tomorrow and day after tomorrow. On this platform, you will see the material that has been uploaded. So assessment modalities, which ma'am explained, that the document is there along with this assessment sheet. So if I click here, I'll get a Word format. And what ma'am explained you, that you fill this Word format, but when you fill the Word format, do not delete your earlier data. At the end of the FDP, you should fill the assessment sheet. So every day you are going on filling, but this sheet will remain one and only one. Okay, it will be a common sheet that you should take care. So this is the first point. Now second point is, I'll go back to the Moodle. Now on this Moodle platform, you will see some of the collab notebooks. Okay, so you will see here the Rocky Sir collab 8th December morning and the time. These collab notebooks have to be downloaded and kept ready. If there are any data sets, data link into that notebook, I will recommend, he has not told me, but I'm recommending you read the collab notebook. If any data set is there, download. He has given specially these notebooks this time because data sets probably are quite large and it takes a lot of time for downloading. So he wants to save that time during the session. Okay. So for 8th morning session notebook is there. 8th evening session notebook is also uploaded. Then 9th morning again he is going to take the session, and 9th evening he is going to take the session. Based on the earlier feedback of FDP1 and FDP2, he has included Tableau. So this will be based on the Tableau. So he has given some tryout examples and a PDF. So now I have already sent an email to all the participants. I hope you have received that email about the Tableau installation. I just want one of the participants to received or not, yes or no. Have you received my email?
Yes, sir, received.
Yeah. So please keep it installed, because that is a special request from Rocky sir. He said that those who will not keep it installed, I am not going to waste time for them. So keep it installed. Installation instructions are already being given. If I open my email, so this is the email by Rocky sir, and you can read all those things. Along with that, he has also given one data in the Excel format, I suppose. It is for something called as superstores, right? Keep that also ready. Because Rocky sir has got this time, not many sessions. He has got 2.5 days as per his availability. And therefore, we don't want to waste timing on those things. So keep everything ready. That in fact, that data set, superstores for Tableau, I have kept it over here. Okay. So this is the main purpose of addressing you today, because tomorrow complete session will be taken by him, and day after tomorrow also almost 90% session is by Rocky. Correct. So please keep these things ready. Now, what madam was trying to explain you was assessment that is available over here. So every day you go on uploading this assessment sheet, learning evaluation sheet, but keep the sheet same. Do not delete the earlier data. Okay, only one common thing. And other final quiz will appear over here itself on the last day, which will be compulsory. Now, those who are new participants, just few informatory things I would like to tell them. Others already know that this is our YouTube channel, right? This is the YouTube channel on which you will find all the recorded sessions, including past recorded sessions, FDP1, FDP2, right? Many times new participant tells us that, sir, kidhar hai, mili nahi raha, we are not getting the videos. So see, this is the live session which is going on. So if I click here, I'll get the live session. If you want to know, let us say morning session. So if you click here video, click on the video and then uploads. If you come here, you will get past live streams. All the past live streams will be available over here. Green colored, I have created background for this particular FDP. So morning session, FDP morning inauguration, entire inauguration session video is available. Remember one note of caution, these recorded sessions we are providing you because we want to maintain this data. This data should remain as long as this channel is available to you. One point. Second point is, if you have any connectivity issues, you are not able to join the session, then you can see at these videos at any point of time. while attempting quizzes, etc., solving your assignments. That time also you can refer all these things. You can pass on these videos to anybody. We don't have any objection on that. You can enroll your students, your colleagues, etc., etc. No problem, right? However, as a participant, you must join the Cisco Meet for your attendance, everything. So attendance will not be recorded based on your YouTube, whether you have joined YouTube or not, or seen YouTube or not, etc. It will be only on the Cisco WebEx platform. So you should appear on the Cisco WebEx platform and you should learn. If you have any issue, we do understand. At that point of time, you refer these videos. So I hope I have cleared everything. New participants, Moodle login will be created today night. Tomorrow morning, you will have your Moodle logins ready with you. So don't worry about it. Okay, done. Any questions from anybody? If no questions, we'll start the session. If you have any question, you can ask me. This is specifically explained because new participants, many times they go on asking the questions on WhatsApp. Others, they know how we go ahead, right? Any question? Anybody who is new in the list can say that, okay, I am the new, but I understood the procedure, because I can see all, majority of them are old. I can see all the names. You are new, but who are they? Aarti ma'am, yes. What I said? Yes, sir. Very nice. Okay. So even if one participant understood, that means I assume that others are also there. So Pooja madam, are you ready? Go ahead. I don't know. She's taking a break. Acha, Jinali, Dr. Jinali, also says, okay, good. So as far as your other assessments are concerned by the resource person, I don't know who will give what, but one assessment will be definitely be given by Mr. Rocky. I requested him, and he is going to give you, and he will give you 2-3 days to solve, and that will be on Tableau platform. Second, preferably will be by our Pooja madam, because she is having a hands-on session on one of the day, so she will give you one of the assessment. It should take hardly 1 or 2 hours, something like that. We are telling to the resource person. It should not take much time. And third one probably will be given by Mr. Govind Goundalkar, who will be taking your sessions on Tiny ML and IoT platforms, right? So probably he will give you. That's it. Others are all kind of case studies, because this is an application. Data science and its applications. So wide variety of applications we are going to study in these sessions. Pooja madam?
Yes, sir, I'm here.
Okay, you can start sharing your screen.
Yeah,
our job is done. We are done. You
yes.
Continue.
And definitely there would be one assessment from the session which is on the 11th.
Yeah. Okay. Yes. Because we believe assessment drives the learning.
Exactly.
That's why. If we do the assessment, then only people learn and see the video. Otherwise, nobody is bothered.
Absolutely.
Weak that people are afraid of and don't do anything. That is also there. So we are trying to maintain a balance of both.
Yeah.
So I hope all our senior faculty members, they do understand our concerns. So, ma'am, you go ahead.
Yes. And it should be something where it creates some interest in them. Okay, I'll share my screen. So is my screen visible?
Yes, ma'am. Yes. And you can also interact. Participants, please. You can interact. You can ask. You can discuss. Nobody has stopped you.
Yeah, participants, you can interact. In fact, we will start interaction now. Most interesting part of this is machine learning to deep learning journey. And when we are moving learning to deep learning, what we do to connect, evaluate, correct, and train madly. There are certain points which are gone in other classes. We need some models which are only time formalizing learning over chain learning. But this is
Madam, your voice is breaking now. Yeah, you are connected, but your voice is breaking.
1 second. Yeah. Is it okay now?
Yeah, it's okay. Go ahead, ma'am.
Yeah, participants, look at the image, and as a human, how do you identify this image? What do you say about the image? Yeah, anybody has given any answer? Yeah, come on. As a human, whatever you want to say, say. Yeah, child playing. Perfect. Dr. Kranti is saying child playing. So this is how we look at the image. Mom helping child to play. Correct. So this is all human intelligence put to it, and all with all our intelligence. Yeah, child learning. Yeah. So these are certain tags we attach to this particular image, and see when we look at the image, we see what are the things in the image. We recognize those objects, object detection, and then explanation. So using our intelligence, we try to recognize the object, and then with our natural language processing, we try to form a sentence. So that's how human does it. Now just see what computers are capable to do. Right? Look at this, and this is two young girls are playing with Lego toy. This is what one of the deep learning model will give you the tag for this image. So it not only identifies that there are two young girls, but they are playing with Lego toy. And also look at the grammar, look at the how the sentence is formed. That also is done with the natural language processing. So deep learning model, which is already trained model, and if you give this image as an input, it understands this. Okay, so what do you say about this image? Anyone? Any title? Yeah, at least one or two titles from the participants. Recognize this image? Okay, swimming. Yeah, anyone? Any other title? A boy jumping. Okay, jumping. Correct. Now see the wonders. A boy is doing backflip on wakeboard. See, this deep learning model detects this. So it's a wakeboard, and it is not only a boy. Boy is doing a backflip. This is what your deep learning model will identify, not only the objects, a human being, it identifies it's a backflip and it's a wakeboard. And it is forming a proper statement like a human forms. Yeah, now quick. Anyone, any guesses for this image? Do it fast so we will be able to complete the things before 10. Playing guitar, correct. Man playing guitar, boys playing guitar, correct. Yeah, a young boy playing guitar, very good. Now look at what the model says. Yeah, playing guitar, boy playing guitar, correct. Man in black shirt is playing guitar. So this is the prediction. So deep visual semantic alignments for generating image descriptions. This is the project, and this project gives this kind of titles looking at the images. Just example of what image processing, not only image processing, but the deep learning applied on the images can work and can do these kind of wonders. So it's not only a deep learning on image processing, but it's a deep learning with the NLP. We need to train the model for natural language processing and framing the proper statements. Look at this. Now look at this image. You see one image over here, right? Now this image, now how computers look at the images. So as we know, the computers know this is the language of zeros and ones, and it only knows the number. So everything is defined and explained in the number. So any computer or any device will look at this particular image as just the sequence of the numbers. So it's the from this corner to this corner. From all these corners, it's all are the pixels, and these pixels have the values or intensity levels, which are again the values maybe RGB, red, green, blue, red, green, blue dots having different intensities, and it's nothing but just the vectors of the numbers. So this is how computers or the devices look at the images, just the sequence of the numbers. Above that, slightly higher level representation, and about that higher level will identify he is a man, he is sitting, and what the scene behind it, etc., etc. So there are certain layers onto it. At the core level, there are the numbers. So based on those numbers, your deep learning model will try to learn what kind of a scene it is. Okay? So create algorithms that can understand the scenes and they describe them in natural language, then can infer semantic concepts to allow machines to interact with humans using these concepts. So not only identifying the images, putting them in a natural language, and also interacting, understanding the semantics, and then interacting using those concepts. So it has gone beyond that. So what we need, it needs the abstraction levels. So we need to create those abstraction levels like image pixels, then objects in the image, then how they are doing the interactions, and the scene descriptions. So this is how it works. So deep learning aims to automatically learn these abstractions with little supervision. Now what does this deep learning do? So deep learning learns automatically. It is like a black box. As in the previous session, in the before the break, I had said it's a black box, and it's like a child learning something. Sometimes with supervision, sometimes without the supervision. So it just learns everything. And motivation goes like our brain neuron. So how this deep learning came in picture? So it's a human neuron, a biological findings inspire the development of neural net. And this is how neural network came into picture and what it has. So it has a biological relation in input, dendrites, output, and human computes using net. See, when we want to mimic the human brain, we really wonder, what all information our brain stores. See, we can not only see the text and the numbers and the images, we hear sounds, we have emotions, we have moods, we have choices, we have, many things like, there's a love represented in the brain, there's a hate, there are arguments, everything, and every other thing is, related to every other thing. And that's how brain is capable of not only, storing those things, those emotions, or that very data, we call it as a data, because it has a sound, it has a video, we have a flashback, we remember our experiences. So what all it has, it stores in the neurons, and these neurons have this logical function, and they are connected to every other neuron, and there is a chemical associated with these dendrites. And when these neurons fire, they can retrieve the information which is stored into it. So that's about the motivation of a human neuron which is in the brain. But now how deep learning works? and how different deep learning is from the machine learning. So the basic difference in the machine learning and deep learning, just remember our earlier example in learning, it is about the cycle and the car, and we had the extracted feature vectors and all. So there we have the features and feature vectors and the feature engineering into it. Now, how about deep learning? So deep learning is a black box kind of a learning, and see this describing your data with the features a computer can understand, and this is the learning algorithm. I will show you over here the difference between the machine learning and deep learning is this is the input, this is the feature extraction and then classification, and then you have a model inference, whether it is a car or boat or something. So machine learning, you have these as two different activities, feature extraction and classification, and there is a so much of human intervention into feature extraction. So an engineer has to work on the this feature extraction, dimensionality reduction, maybe your principal component analysis kind of algorithms. You need to have some intuition, you need to have some insights on the features extraction as an engineer. So when you are dealing with the machine learning, now these both the steps together, we need not have any human intervention for feature extraction for deep learning. So both the things come together here, and it reduces the human intervention for the feature extraction. No need of feature engineering into deep learning. So it becomes a black box. So just you need to have a data, give that data to your deep learning model, and deep learning model will itself do the feature extraction, classification, and your model is ready for further testing or further work. So seems easy. Does it seem easy? It has become easy when you are working with certain platforms. Now on 11th, we have a session 10 o'clock, which is a convolutional neural network. And in the evening, we have a hands-on, and we will see how to train the models using the actual data. And it's really very interesting, but it learns and gives us the results. So DL started outperforming in 2010 from other machine learning techniques, and first in speech and vision, and then in NLP. Now, deep learning is outperforming in every other area wherever there is a huge data. So if you have a huge data, you can definitely have a deep learning model trained for it, and it will work better than machine learning. And that's how we have now left behind the AI and machine learning. Wherever we feel that the human brain works here, deep learning will work definitely in that. What we need is a data and high computational power. So what exactly deep learning, and why it is generally better than other methods on image, speech, or certain other types of data? So the answer is this. So deep learning means using a neural network with several layers of nodes. So it's not just one layer of node. Like in brain, we have neurons connected in several layers, and every layer is working for the different way or for the different abstraction level. So like that, we can train our model in deep learning between the input and output. So there are certain layers, we call it as a hidden layers, and those hidden layers do the wonders generally. The series of layers between input and output do feature identification and processing in a series of stage, just as our brains seem to. As we have seen here in the diagram, that there is a feature extraction and classification in machine learning. But the deep learning, these different layers. So these are the layers, they will do both this work. And also it will improve the learning so as to improve the predictions and analysis. Now, this multi-layer neural network were already there. It was there since 25 years, but now why again there is a sudden, leap in deep learning? For the reason, because we have now huge data and the computational power. That's the reason behind it. Now, We always have good algorithms for learning and the weights in networks with one hidden layer. But now what we are doing, we are using the several layers for learning algorithms. And that's how we get a deep learning model. So we have the deep learning in and the learning in every layer in this model. Sir, is it okay if we have a little extended time?
Little
Hello?
means how much? हाँ madam, little means how much little?
So if 10-20 minutes more?
Okay.
Or
Yeah.
faster?
Yeah, 10 minutes, 10-15 minutes is okay.
Okay.
Otherwise, you also have a session on that CNN. That time also you can continue. But 10 minutes is perfectly fine, ma'am. No problem.
Okay. And actually, I had a wonderful video to show. Maybe a link I can put up in a chat box, and after this session, all participants can see. So I can save my time in the session. They can see the video later.
Okay.
Yeah. So we have a neuron in the brain. Same way we have a neuron, and this is one node. We are mimicking this node as a neuron in the brain, and our neuron learns and stores and works on it. So this is one node, and for this node, this input, just consider this particular example, this node. Input is coming from here. So there are three inputs for this particular node. The input is minus 0.06, minus 2.5, and 1.4. These are these, and there are weights associated with this. And what does this do? This particular node will learn from this, and it actually converts into the output. So it actually has a formula for this. So it multiplies the weights. These are the weights. Now initially we will have any random weight. These weights are multiplied with the input. So input into weights, and this is the weighted average for that. This is the weight. And what we get this as the output. So this is the simple function this neuron performs. And every neuron will be given the input. It will be given weight. These weights on the input will be multiplied, and it gives you the output. So this 21.34 is the output given by this. Now look at this. We will see one sample example, how deep learning works. We have seen there is an input layer, there is an output layer, there is a layer or hidden layer. Now let's understand there is one hidden layer, and how does this neuron work, and gives you the input, and how it works, and how it learns. Just see this particular example. So we have a simple data set only for understanding. We have this data set, and these are the classes. So this is the labeled data basically. There are two type of classes, 0 class and 1 class. This is the data set. These are the 4 records. Okay. Now training the neural network, how a network is trained. Look at this. So initialize with the random weights. So initially you will have the random weights, and this is your pattern. So 1.4, 2.7 and 1.9, these are the values go in. So this neuron will have these values, and here is the output, which is the 0.8. But this is the class 0. So what should be the answer? 0 should be the answer. Right? Now when we have these as the input, so these are the inputs, and this is the output, because what did we do? We had the initial weights. So we multiplied with those weights, initially random weights, and we got 0.8 as an answer. But look at the label, we wanted 0. So there is an error of 0.8. Now what do? We have to change our weights so that what are those values here, if we associate those values and multiply with these numbers and get a value which is lesser than 0.8 and which is now nearing to 0. So we will change our weights accordingly. So change the weights. So whatever weights we have, we will set those new weights by little bit adding and subtracting those weights, and we try to get that value as a 0.8. If we get a 0.7, again we will change those weights, we will get 0.6. Then this is how we go on changing the weights, and finally we will get here 0, and for those set of weights will be assigned. Okay, so this is how it is. As I said, black box, because it knows only the numbers. It is multiplying with the numbers and it is adjusting the numbers, so that for this input we should get this output. So what should be the multiplier factors? That's what it finds out, and those factors have to be constant when you are working on the another record. So it takes, now for an example, it takes this as a record, and so it goes as input 6.4, 2.8, 1.7. It same weights would be used for that, and now it gets 0.9. But what should be the label data? Label data says it has to be 1. So what's the error? Yeah, any participant? What's the error here? We wanted 1, but we are getting this weighted addition as 0.9. So what's the error? Quick answer. Is it 0.1? And the sign? Minus. So the error is 0.1, very good, but the sign is -1 because you are saying 1 and it has to be 0.9. And that's why you have to now change those weights. Okay, so after changing those weights, you get another weights, and those weights have to be changed in such a way that your earlier records will give the same answer, and the answer should not change for the entire set of records. So this is how just go on changing those weights. So this is how you complete it for all your records. Now only for simplicity we had 4-5 records, but this is done for if you have thousands of records, this particular phase is repeated for all those 1000 numbers, and then you get here certain values. Now for every this blue line, it's a weight. So all these are the weights, and those weights will be taken, and again this entire thing, when you come at the end of this, so end of your records or end of your data set you reach, you are going to repeat this thing, and that is called an epoch. So this one epoch or iteration, in simplicity we can say. So this is one iteration is completed, and now you will complete the second iteration, and those changed numbers of these weights, again you will try to find out and bring those numbers closer to the labeled. So whatever are the weights in the earlier epoch, you will change the entire set of weights based on adjusting it. You will adjust it so that for this record you get 0 and for this record you get it 1 for the same set of values, and these values are the weights W1, W2, W3 for these lines. So this you repeat for multiple times, and these are called as epochs. So 10 epochs, 20 epochs, sometimes hundreds of epochs you will have to perform. So just understand, it's highly computational process. It involves high computation because you are only working on the numbers. Now here are only 4 numbers, the 4 records. Generally these are the 10,000s of records and sometimes the millions of records. So millions of records and millions of feature vectors. So those columns here I can see only 3 columns for that. Okay, so these are the features and this is the label. It is possible that there are hundreds of features in the data, and that hundreds of features together, millions of records, you perform this weight adjustment thing one after another epoch, and finally your network is trained to predict if similar kind of a data you give, similar kind of a output it will give, and now this model is ready for the prediction. So everybody understood the core of neural network, how the neural networks are trained. Now look at this particular example. Consider a classifier which we want this points, data points, the red data points and yellow data points to be classified. One of the machine learning algorithm we have seen the linear classifier. So if we have a linear classifier over here, we may classify maybe something like this. or we may classify something like this if it is a linear classifier. But linear classifier will no more be a suitable classifier for such a data or data point if you plot it on a graph. So we need a decision boundary for classifying whether it goes in this yellow classification or the red classification. That's a decision boundary now. It was a linear classifier in the machine learning. Now it is no more linear, so it is a decision boundary, and this decision boundary is very complex. If I want to classify in a perfect or a good accuracy, I need to mold this decision boundary. Now look at this. Still, these are few records which are this side, and still there are records that side. So yellow are this side, some yellow are this side. So this is not a perfect decision boundary. Now this decision boundary has to be perfect, and we need to run it for maximum epochs, having maximum neurons and maximum layers in the network, so that this boundary becomes more accurate and it classifies these data points accurately with the good accuracy. Now look at this. Just look at how this boundary changes. See, adjusting the weights. So you go on adjusting the weights one after another epoch, and this boundary changes, and further it changes, and now it becomes a complex boundary, and eventually this is a perfect boundary which classifies the yellow samples and the red samples correctly. So this is a complex boundary. Now you can definitely compare it with the machine learning model, which is a linear boundary, right? And deep learning gives us such a kind of decision boundary, which is very, very complex in nature. And how it does it with more number of neurons, more layers, more number of epochs. It goes on becoming accurate and accurate, giving us this complex. And that it does with the black box kind of a thing. So when learning algorithm for nets are dumb. See, we say intelligence, but in deep learning, no, what it does just adjusting the numbers. So what is the intelligence in that? Basically, we may say that it's just a dumb algorithm which only adjusts the weights. So by dumb luck, eventually this tends to be a good enough to learn effective classifiers for many real applications. Even though it is dumb, it works in a fabulous way because we train the model for more number of layers and continuously for adjusting the weights. Now, just yeah, look at this. Now this is the input layer. This is the hidden layer, and this is the output layer. And all these input layers, so every neuron in the input layer, it is connected to the every neuron of the hidden layer. And in this hidden layer to output layer, all the neurons in the hidden layer are connected output layer, and whatever arrows you could see this. So these all arrows are the weights. So these are the weights, and there's an input flowing from every one neuron to another neuron from previous layer to the next layer. Now, as this X is the input, H is the hidden layer, and Y is the output layer. Look at this, what it calculates. So W1 into X plus B1. So B1 and B2, these are the two biases. We will see the biases and those activation functions and all in another section. So right now we'll understand the basics of deep learning and how to train neural networks. So X is an input vector and W1 is a weight vector. So this vector multiplied by these weights will be given, and there would be one bias to it, the same bias for input vector, and this is how H will be calculated. And how well Y will be calculated? This H neurons multiply by weights and its input, which comes from the previous layer, that's the output. And here in the output layer, there are 2 neurons, so it will give us the output in Y. Now here we have seen this function. We will understand what it is. Now look at this. How many neurons in the hidden layer and output layer? 4 plus 2. Okay, so 6 neurons. So how many weights are there? 20 weights. And because there are 6 neurons, we have 6 biases, right? So how many learnable parameters are there? So there are 26 learnable parameters. These are 26 values which will be set. So we have the input and we have the weights and we have the biases. So what will change? The weights will be changed accordingly for training the model. Okay, so these are the weights. These are the activation functions. How do we train? Like this. This is the sample data, batch-wise, then forward it through the network, get the predictions, back propagate the errors. So as we have seen in the diagram, it is changing the weights based on our labels. Update the network weights and continue this and continue for multiple times, for multiple epochs, and you reach to the good approximation. Now when to stop? When do we understand that we have learned properly, or we have learned where we can do proper predictions, and what should be the learning rate? So we need to have one function which will tell us now we should stop, and that function will tell us when to stop and how much should be the learning rate. Okay, so the function and the gradient function tell us whenever it converges, we can stop there. And what should be the learning rate? The learning rate, for example, I will show you here the gradient descent. Now, when you are learning, look at this. So this is the cost function and these are the weights and you are learning. So maybe you are here and you are learning. So you change your learning rate. So we have to change our learning rate so that we reach here and the cost function is minimum over here. So once the cost function is minimum, yes.
Pooja madam, a blank screen has become blank suddenly.
Oh, I have shared one second, because I have shared only the presentation. Yeah, is the screen visible now?
Yes.
Sorry, I made a mistake. Yeah, so this is the cost function. So cost function increases this side, cost function decreases down. And for example, if we are here at the state, we have to go on revising our epochs. So we continue our epochs and this is our learning rate. Now, if the learning rate is very, very low, we may go very slowly. Now here is the gradient descent. This gradient descent converges here. Here is the minimum value for the cost function. So cost function is minimum. Here we get the highest value for the prediction. And this is the most accurate model prediction here, right? And if we are here, we want to go from this step to this step and we want to take a step. Now it's a trick. Our learning rate, if it is very low, then it will take more number of epochs and slowly we proceed and we reach here to the minimum. If it is very less, the rate is very less, we take more number of epochs and more number of and the maximum time it will take. if we take the maximum step, it is possible that we are here and we take such a bigger step, we may cross over this and we reach here. It's possible that हम लोग इसको छोड़ के यहाँ पे चले जाएंगे if take a bigger step, right? And we miss our this local minima where the gradient converges. So that's why our learning rate has to be proper for that data set, so that and that's called as a overfitting. If we are here and we take a bigger step and we go here, then we understand, oh, the minima is at the backside, and we take a step, a learning rate, a negative learning step, and we go here, again we miss our minima, again we miss our minima, and that is called as a overfitting. And underfitting is what? Our learning rate starting from here, the rate is so low that we do not reach here in the specified time or the specified number of epochs. And the function, which is a cost function, which tells us when to stop, is a gradient descent. Now we'll go back again to our presentation. Yeah, so look at this. So this is the gradient descent. Now the gradient descent is reaching to the local minima, and we set up our learning stay rate depending on how this gradient descent moves. Look at this. So this is how we have to take a step so that we reach to the local minima using those weights. And that gradient descent, once it converges, we reach to the local minima, we stop this training. So it is a cost function or the objective function. Right now we will not go in very detail with this mathematics, but this is how the activation function and this local gradient will tell us whether we should continue our learning or not. Look at this activity. So these are the weights, these are the biases, and this is what we get a value. And the activation function. So after applying the activation function, we will come to know whether the values are very positive, negative, or very negative kind of a thing. Activation function. Now non-linearity is needed to learn complex representations of the data. Otherwise, then neural net would be just a linear function, right? We didn't want the linear function and the linear classifiers that's there in the machine learning. That's why we moved to deep learning. So we want the non-linearities to be looked at. And that's how, look at this classifier. So 3 hidden neurons will give you maybe a classifier like this. Still here are green dots and there are red dots. So this is with 6 hidden neurons. Look at this. So more complex boundary to classify in a better way. This is the complex boundary which classifies it in a perfect way where the all red dots and green dots are properly classified. Now activation function. I'll extend it a little bit. So just look at the activation function sigmoid. Now look at this data. So whatever the answer you get, sometimes we need that answer to be fit into 0 and 1, right? So whatever is the answer, then activation function will translate it and will fire it into this particular range, and that's the sigmoid function. So that is the activation function sigmoid. Now tanh function. So tanh function will map your values in the range from -1 to 1. ReLU layer. This ReLU layer will give you this kind of a value where it is positive or negative. It will map so that it is faster, less expensive, and more expressive. It also works and it prevents the gradient vanishing problem. So we will also understand the gradient vanishing problem. These are the things we will take forward in the next session. We will see more on activation functions and which activation function to be used on what kind of a data set, so it gives us a better result. As I said, overfitting and underfitting. So there is a diagram here. Look at this diagram, error this side, and these are the parameters you are training it. So if you take the larger step and the smaller step, we may have a chance of crossing our local minimum. And look at this data. Sorry. Look at this data. Inadequate, and this is the complex boundary, and that's the overfitting problem. So this is a fairly good enough kind of a classifier which classifies those data points. So linear may not work. This kind of a complex boundary may be overfitting, but this kind of a good compromise can be done, and we can fit it properly with the help of the gradient descent. Look at one example. These are the digits. These are the handwritten digits, 0 to 9, and how a deep learning model will. So these digits, now look at this particular matrix which specifies a digit. Just 1 second. Can you close the door? The feature detectors. Now here we need not, we need not do any feature engineering. So all these pixels and the position of 9. Look at this handwritten 9. This is the image of 9, which is a handwritten 9, and this is how it is oriented. And every pixel, the position of the every pixel and the intensity of every pixel will become a feature for this particular image. So this is how many pixels you have in the row and how many pixels you have on the column. So here see 63, 1 to 63. So 63, 64 pixels are the feature vector for each image or each sample in the data point. Now look at this. So this is one row, or this is how the features would be extracted. So abstraction levels are pixels, abstraction levels are the rows, abstraction levels all are also columns or maybe smaller matrices in this. And that's how it recognizes those features, and deep learning model will capture those features. See, and these features will be captured like the vertical lines, the horizontal lines, then the curves, maybe the rounds in the numbers. So it will automatically learn how does 6 look or how is the 7. So there is a one horizontal line, one slanting line. So there are 2 loops like this. Deep learning model learn the features and how the numbers are represented because we give the label to these images. So every image is a different image and every image will have a label whether that image means a number 1 or 2 or 3. So it extracts those features automatically. Now look at this. So it extracts those features. And multiple layer, as we said, multiple layer makes sense because the humans also have the brain, which is a layered brain. And every layer is responsible for different level of or separate level of abstraction. And that's how it is a new way to train multi-layer neural networks. So training the layers. We have seen one example with the numeric that was a single layer, right? So this is the multiple layer. So multiple inputs will be passed from a previous layer to the next layer, adjusting all the weights through the iterations. Okay. And that becomes the autoencoder, which will encode automatically what weights, what vectors, what features it has to learn. And finally, once it predicts the class. So if you look at this is only one at the output layer. So it will predict one class. So whether particular input belongs to that class or not. So that's the basic idea. So this is how the basics or the core of the deep learning. This is how we train the model. It's all about the numbers and adjusting the weights, running through epochs and checking whether your learning rate is right and whether you have reached to the proper step where you can stop. Look, and from since 2010, using this deal, the world is seeing the wonders. One second, Darla. So what are the areas it is ruling now? Natural language processing, machine translation, sentiment analysis, dialogue agents, question answering, text classification, and everywhere where we use the human brain, we can replace those activities which are monotonous or where intense calculations, we can replace it with the help of deep learning. So this is all about the basics of deep learning. These are the references which I have used. That's it from my side in today's session. So just a map from AI to machine learning to deep learning. So this is how we have proceeded from the applications and the areas where we can use the AI, ML, and deep learning. Yeah, for any questions, the forum is open. Sir, over to you.
Ma'am, one question is there in chat box.
Yes.
Chat box, ma'am. Can you see?
One second. Let me see where is the chat box. What's this? Yeah, is there a question in the chat box?
Yes. That's okay. I'll read. How do systems handle when image size is in pixels is not the same?
See, when we are using deep learning and features. Hello.
Yes, ma'am. Continue.
Yeah, we have to have for when we are training the network, whatever features are there, they go in the columns. So just imagine a huge data which is represented in rows and columns where you have several columns. Those columns are the features. In image, those columns are the feature or the pixel intensities, and horizontally you have the data set. If the images are not of same size, we'll have to have pre-processing done on the image, and we have to convert every image in the same size so that we get the image into pixel size. So we may reduce all the images of the same size, maybe 64 by 64 or 256 by 256, so that you get a feature vectors of same size. We'll have to work on the images. Images have to be transferred to the same size.
So as of now, I don't think, madam, any other questions are there in chat box. If anybody wants to unmute, can unmute and ask. But anyway, you are already available on the another day, so that time they can ask.
In fact, yeah, we can have some questions in hand. And we can take up those questions on 11th morning.
Okay. Yeah. Pallavi ma'am?
Yes, sir. Yes, sir. Okay. Thank you very much, ma'am, for the informative session, starting from AI, ML to deep learning. It was really wonderful. And the examples that were given by you were really nice and helpful. Thank you so much, ma'am, for the very informative session. And ma'am will be with us for a couple of more sessions. So we'll be looking forward to it, ma'am. Thank you so much. And thank you, participants, as well. Sir, any instructions from your side? If you want, you can give.
I think I have already given sufficient number of instructions.
Okay. Okay. So somebody was asking about the feedback form. So all have to fill. Somebody was asking, sir, in chat box, do we need to fill the feedback?
Yeah, that
Everybody has.
come feedback it is. In the chat box, there is a link. It is called as attendance come feedback. It's your attendance as well as feedback both together. There will not be a separate feedback link. It's the same.
Everybody has to fill that.
Same link. Everyone has to fill every day same link. Thank you, Pooja madam. Thank you very much. Very nice and very good examples. You have justified the title of the workshop, Insights into, and then Intelligent Automation, Machine Learning, Data Science. Starting also you have justified of the title, and end of the title also you have justified Data Science and its applications. So a very good session on Thursday. Morning we had an interesting session. Yeah, morning we had an interesting session from Napinay ma'am. She is anyway a stalwart in this domain. Nobody can beat her in the country actually.
Yeah.
And this end, and end of the day is also very good. Very simple examples you have shown, and person like me from electronics background who was not knowing ABC anything, now after going through FDP1, FDP2, and now I am actually understanding what is happening. I'm trying to correlate everything. So, and in a simple manner, you tried to explain that. That was very nice. Your examples were very simplified, and I can understand that how much time and the devotion we would have given for preparing the slides, because your slides were very nicely prepared. Yeah. So thanks a lot for that.
Thank you.
Yeah. Yeah. So now you have raised the bar actually. So people will be looking for your next section also. More than this, the deep learning, again more deep.
Correct.
Okay. Thank you, ma'am. Thank you very much. Yeah. Okay.
Interesting video for the participants who will really love the deep learning from that moment video. I'll give the link so that you can pass it.
Yeah, you can email me. You can email me the link. I will put it on our Moodle platform. That link. Anytime, always it will be available.
Yes.
And you will be providing the slides or some material.
Yes. Yeah, I can.
Yeah. Then email those also. I'll put it on Moodle.
Sure, sir.
Yeah. Thanks a lot, ma'am. Thank you very much.
Thank you so much. Thank you, participants. But I don't want this, silence. We have to break the silence now.
That is very difficult, ma'am. I'm trying from last. But there are few. I can see there are few names. If you interact, they will interact with you. Dr. Chetna is there, and Kranti ma'am is there, Bipin sir is there, Nirbhay Chaubey sir is there, Inderjit is there, our Manoj sir is there. They do interact. I know. They are going to interact with you. Apeksha ma'am must be there. I am sure. I can't see her name, but she was there. They are going to interact. You just wait for the next session.
Yes, I'm also excited for the next session. Thank you so much.
Yeah. Nirbhay sir, namaskar. Welcome, sir. Welcome.
Thank you, sir.
I hope you are enjoying the sessions.
Yes, very much. In fact, busy going on with university schedules and parallel.
Yes, yes, sir. Yeah,
So
I can
it is
understand. I
good
can
that you
understand.
have managed the things in the evening. So that is the reason that I managed to attend
Yes.
this.
Yes, sir, because it's not that as an organizer we are also free. We are also
Yes,
doing
yes.
all the things that you are doing, right?
Yes.
We are doing our assessments, exams, and everything.
Yeah.
So between 2 to 5